Question number 33, this is from the chapter Triangles. We have to do one proof and then apply that proof to solve the second part of the question. So it's got two parts, part 1, part 2. Check out what this part 1 is. Prove that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Recall what this is. We're talking about basic proportionality theorem, right? So we're going to prove basic proportionality theorem. That's going to give us a significant amount of marks for this question. Second part, we're going to be applying this basic proportionality theorem to find out the value of EC in this diagram. We'll come to part 2 in a while. We'll start with part 1. Let's prove basic proportionality theorem. Quickly be done with it. It's going to take us about 3-4 minutes to finish that. ABC is a triangle. I'm going to draw a line parallel to BC. We'll call it as DE. DE is parallel to BC. What is expected to prove? Line draw parallel to one side of the triangle, cuts the other two sides at distinct points D and E. So it's not drawn at A, at D and E. And this line divides the other two sides in the same ratio. The other two sides are basically AB and AC. It's going to divide it in the same ratio, which means AD divided by DB is equal to AE by EC. So to prove, what are we trying to prove? We are trying to establish this relationship. How are we going to go about it? We're essentially going to find out areas of 4 triangles and then find the ratio and do something about it. Let's start with the first one. I have to draw 4 lines. Let me start with the first 2 lines. Both of these lines are drawn to triangle ADE. Both of these are altitudes to this triangle to 2 different sides. To side AD, I'm going to draw one altitude. We'll call it as EG, we'll call it, right? To side AE, I'm going to draw another altitude. We'll call it as DF, right? So DF is one altitude, EG is one altitude. So step 1, let me find out the area of triangle ADE. In one of the instances, I'm going to take AD as the base, and in the other instance, I'm going to take AE as the base. So first part, find out area of triangle ADE. Take AD as the base. Half into AD into what is the altitude? Altitude is EG, perpendicular drawn from the opposite vertex. Second, I'm going to compute the area of the same triangle ADE. So it's going to be half into the base this time is AE. So the altitude is a perpendicular drawn from the opposite vertex, right? AE being this side, the opposite vertex is D, so the altitude is DF. Obviously 1 is equal to 2 because we're finding out the area of the same triangle ADE. Now this becomes a little interesting. We'll start by finding out I'm going to draw 2 more lines. Let me start with one line. Let me draw BE to start with. I'm going to look at area of triangle BDE right now. Area of triangle BDE. To find out the area of this triangle BDE, I can take anything as a base. I'm starting with BD as a base. Half into BD is my base. In triangle BDE, taken base as BD, we'll have to compute the altitude. Altitude is a perpendicular drawn from the opposite vertex. To side BD, the opposite vertex is E. Perpendicular from E to this line BD. BD and BA are the same line, happens to be this EG. So for this triangle BDE, the altitude is outside the triangle, but the altitude is the same EG as what we had for AD. So essentially the area of this triangle is half into BD into the altitude, which is equal to EG. So I've done one part. Fourth one, after drawing one more line, we'll finish it. I'm essentially going to look at this line, drawing CD as a line. Finding out area of triangle CDE, area of triangle CDE. This is half into, I'm going to take EC as the base, right? For this triangle CDE, I'm going to take EC as the base. If I've taken EC as the base, the vertex opposite to EC is basically D. Line perpendicular to that to EC, CE, CA are all the same, which is essentially DF. So the altitude happens to be equal to DF. We're going to do one more thing at this point before we go to the next slide and wrap this all up in a way, right? Look at it, triangle BDE, right? This triangle, we took BD as one base. Another way of looking at the base for triangle BDE, let's go with DE as the base, right? This is a base, this is a possible base for this triangle. Similarly, for triangle CDE, again DE can be the base for it. For both this triangle and this triangle, DE could be the common base. Both these triangles have the same base. and they are in between the same two parallels DE and BC, which essentially means that their altitudes are going to be the same, which means the area of triangle BDE with DE as the base and area of triangle CDE with DE as the base, because they have the same bases and they are in between the same two parallels, these two are equal. So area of triangle BDE, now I can write this fourth step. I'll write this 4 alone, I'll write it here. This is area of triangle CDE, which is equal to area of triangle BDE or BED. BDE, we'll write it BDE. Is both of these are one and the same. BDE and CDE are one and the same. Is equal to half into EC, half into EC into DF is what we have. Now look at it. I'm going to look at ratio of 1:3. Area of triangle ADE to area of triangle 1 divided by 3 is what I'm writing. This is area of triangle ADE divided by area of triangle BDE, which is equal to area of triangle ADE by triangle BDE, half into AD into EG, half into AD into EG divided by half into area of triangle BDE, which is 3, half into BD into EG. Half gets cancelled with half, EG gets cancelled with EG, so we get AD by BD. I'm going to look at 2 divided by 4. 2 is area of triangle ADE. 4 is area of triangle CDE, which is equal to area of triangle BDE. So this is half into, let's check out what 2 is. 2 is AE into DF. AE into DF divided by 4, we have written it here, which is half into EC into DF. Half gets cancelled with half, DF gets cancelled with DF. So this is equal to AE by EC. What is 1/3? Area of triangle ADE by area of triangle BDE. What is 2/4? Area of triangle ADE by area of triangle CDE, which is the same as the area of triangle BDE. So both these left hand sides are equal. Therefore, both the right hand sides can be equated. So AD by BD is equal to AE by EC. AE by EC. Just go back to the first slide where we drew the triangle and said, what did we have to prove? AD by DB is equal to AE by EC. Is that what we have proved? AD by BD is equal to AE by EC. AD by DB we wrote there. DB and BD are one and the same. So AD by DB is equal to AE by EC. So basic proportionality theorem has been proved. Now that we have proved basic proportionality theorem, let's move on to second part. AD by DB is equal to AE by EC. They've stated this basic proportionality theorem. They've given us values for AD, DB, AE. We need to find out EC, which is very simple. So AD by DB is equal to AE by EC. Plug in the values. AD is equal to 2. DB is equal to AD by DB. Sorry. DB is equal to 6. AE is equal to 3. EC is what we need to find out. EC is equal to 3 into 6 divided by 2. 3 into 6 divided by 2, which is equal to 9. So the measure of EC is equal to 9 centimeters. Before you leave, I want you to do 2 things. 1, sign up at online.maxtute.com to get started with CBSE Class 10 Math online tuitions. It takes all of 5 minutes and less than 3 steps to get started. So get it done today. And second thing, I want you to subscribe to this channel if you already haven't, and turn on notifications so that you get notified every time a new video is uploaded. And also, spread the word about this channel to your friends and classmates.